Good morning, students. In the last class, we have discussed that the reflection of sound taking place in between the interface of two media. That means whenever sound travels in one medium and incident on the interface between on the interface between the two media, then at the interface the reflection taking place. Here there is a sound wave which travels in the air medium and incident on the denser medium, solid medium, that is like a ball, rigid ball, then which is found to be bounced back into the same medium in another direction. That we know that reflection of sound. Then after that we have studied the laws of reflection also. According to the laws of reflection, angle of incidence is equal to angle of refraction, and also the another law of reflection of sound is that the incident ray, the reflected ray, the normal and the reflecting surface all lie in the same plane. These are the two laws which governs the reflection of sound, that are called as laws of reflection of sound. This we have discussed in the yesterday class. Now we are going to discuss reflection taking place at the boundary of a denser medium. Right now there are different media. Some media found to have lesser density. Some other media found to have larger density. Therefore, we know that the lesser density media are called as rarer media. And oppositely, the larger density media are called as denser media. These are the different types of media. Then we know that sound can travel in all the media. That means it can travel in rarer medium like air or gas, and also it can travel in liquid like water. Light also, that means sound also can travel sound. Sound can also travel in the solid medium. It can travel in any solid medium, glass, water, then some other solid medium, iron, and also in all the metals, sound can travel from one point to that of another. Therefore, then that means sound may be traveling in rarer medium, may be reflected by denser surface, or otherwise the sound which is traveling in the rarer medium may be reflected by the denser medium. Similarly, sound travels which are traveling in the denser medium may be reflected by the rarer medium. Then depending upon the based on the reflecting surface, how the reflection takes place in the sound, which we want to discuss in detail in this class. Right now let us consider, first of all we want to discuss reflection of sound at the boundary of a denser medium. Here there is a rarer medium which is a less denser medium like air. Then in this less denser medium a sound wave travels. Okay, then and incident on the interface of the denser medium. Here there is a denser medium. Here there is it is a rigid wall. Rigid wall. Then that is the denser medium. Here the sound wave which is traveling in the rarer medium is reflected by denser medium. Then we know that in air sound will travel in the form of compressions and rarefactions. That is, the sound waves are longitudinal waves. Sound waves are longitudinal waves. Then whenever the longitudinal waves travel in a medium, then we know that the compressions and rarefactions will be produced in that medium. Okay, that means increased density region, then followed by decreased density region, then further increased density medium. Okay, then next again decreased density region. Like this, the compressions and rarefactions are produced in the rarer medium. Then right now such a compressions and rarefactions are advancing along the direction of the wave. Along the direction of the wave. Okay, then right now when sound wave which travels in the air medium like a rarer medium, when it incident on the denser medium, that means now we take that compression is incident on the rigid wall, means what will happen, this incident wave, the sound wave which is incident on the rigid wall will act a force on the rigid wall. Then F is the force which is acted upon on the rigid wall by the incident wave, means then what will happen, the rigid wall also will exert an equal and opposite force. Will exert an equal and opposite force. That is called as reaction. Therefore, reaction R is equal to reaction acting by the wall, which is R is equal to minus F. Then, because of this reaction, what will happen? Once again, the reflection, that means compressions will form nearer to that of the wall, and followed by the lesser denser medium, and compressions and rarefactions will be produced in the reflected wave also. Okay, that is, the compressions are produced very nearer to that of the wall, then next rarefaction and so on. Therefore, in the reflected wave, that means in the reflection, a compression is reflected as a compression. Compression is reflected as a compression. Then the reflected wave, that means the incident wave, travels left to right and incident on the solid wall. Then the reflected wave travels from right to left. Then in that reflection, compressions are reflected as compressions. Compressions reflected as compressions. Okay. Then right now, next, the other type of reflection is that the reflection of sound at the boundary of rarer medium. At the boundary of rarer medium. Then now let us take, there is a denser medium in which the sound wave is traveling. In which the sound wave is traveling. Rarer medium. Reflection of sound at the boundary of rarer medium. Then here there is a denser medium, there is a greater density medium, then in which light waves are traveling and incident on the interface between the two media, that is, it is the rarer medium, that is less denser medium. As already we know that light, in the light wave, we know that there will be compressions and rarefactions. Compressions and rarefactions. Compressions are the increased density region, and the rarefactions are the decreased density region. You will know that. Okay, then right now in this incident ray, the compressions, the alternate compressions and rarefactions are traveling from left to the right and incident on the interface between denser medium and the rarer medium. Then now let us consider there is a compression. There is a compression which incident on the boundary. Which incident on the boundary. Then right now, being it is a rarer medium, then the incident wave will exert a force on the surface of separation between the two medium. Then being the second medium is a less denser medium, then because of the incidence of wave, the surface of separation is bent inwards. Surface of separation bent inwards due to the action of force. Due to the action of force. Then right now the particles of the medium, okay, that is rarer medium are free to move. That is particle free to move. Then therefore these particles are pushed away. These particles are here. The particles of the rarer medium are free to move. Free particles. Then because of the force that will move away. Therefore here even though the compression is incident on the boundary, then because of this movement, this is because of the moving of the air particle, rarer medium particles, then here less denser medium is produced, that is compression is reflected as a rarefaction, then followed by the greater density medium. Therefore, in this case, that is the reflection at the boundary of rarer medium, compressions are reflected as rarefactions. Compressions are reflected as rarefactions. Okay? Then, right now, that means here the force found to be more, then the reaction force found to be lesser. That is, R is found to be, reaction force is less than that of the incident force. Less than that of the incident force in the case of reflection at the boundary of rarer medium. Then next we want to discuss that reflection of sound in the plane and curved surfaces. Reflection of sound in the plane and the reflection of sound. In the plane and curved surfaces. Then here the reflecting surface may be of different shapes. Reflecting surface may be of different shapes. That means the reflection surface may be a plane surface. Plane surface, like the wall, rigid wall, okay, or any solid surface. Then right now, if there is a light wave, a sound wave, there are some sound waves which are traveling in the one medium and incident on the plane surface means, then therefore what will happen? In the same directions, the sound waves are once again reflected. These are the incident waves. Then these are the reflected waves. Okay. Then therefore, being the parallel rays are once again reflected as parallel rays, then there will be no change in the intensity of sound. That means there is no increase in intensity or decrease in intensity of the reflected sound. There is no change in intensity. Intensity is nothing but the loudness of sound. What is the intensity of sound? Loudness of the sound. Therefore, the loudness of sound will not neither increase nor decrease when the sound waves are reflected by a plane surface. Plane surface. Then instead of the plane surface, the reflecting surface may be curved. Then we know that there are two curved surfaces already, which we have studied in the light chapter itself. Then in some cases, the reflecting surface found to be bulged outwards. Such surfaces are called as convex surface. Then here some sound waves which are traveling in one medium and incident on the convex surface, like this means, then we know that the convex surface have a property of diverging the incident rays. That means a parallel ray which travels in one side, which travels from left to right, and incident on the convex surface means then after reflection these reflected rays found to be moving away from one another. Then this phenomenon of moving away from one another, the reflected rays moving away from one another is known as divergence or diverging. Therefore, the convex surface is a diverging surface. This phenomenon is called as a divergence. This phenomenon of making the waves to move away from one another after reflection is called as divergence. Then right now, because of this divergence, what happens? The intensity of the reflected sound found to be decreased. That means the incident sound will have larger intensity than that of the reflected sound, or the reflected sound found to have less intensity than that of incident sound. Therefore, there is a decrease in intensity whenever the sound waves are reflected by a convex surface because of the divergence of the waves. Okay. Then right now, otherwise, the reflecting surface is bent inwards. Means such a reflecting surface, we know that concave surface. Here there is a reflecting surface which is bent inwards, like this. Then this type of surfaces are called as concave surfaces. Now, the concave surfaces, whenever parallel rays which are traveling from one point to the along a particular direction, incident on a concave surface, then after reflection the reflected waves found to meet at a particular point. Then this meeting of reflected rays after reflection by a surface is called as convergence. It is known as convergence. Then this property is known as the property of making the reflected waves to meet at a particular point after reflection is known as converging. Therefore, concave surface is a converging surface. Then right now, being the waves are meet together, the reflected waves, because of the weighting of, because of the collection, that means mating of the reflected waves after divergence, after reflection. We know that convergence, because of this convergence, the intensity of reflected sound, found to be increased than that of the incident wave. Therefore, we have to keep it in mind that whenever the sound waves are reflected by concave surface, intensity of sound found to be increased after reflection. But the same sound waves which are reflected by convex surface means then there is a decrease in intensity of sound after reflection. Then suppose the reflecting surface is a parabolic surface. Means here there is a reflecting surface which is in the shape of a parabola. Okay. Then right now here also the incident waves, the parallel sound waves which are traveling towards the parabolic surface after reflection, they are found to meet at a particular point. Okay, like this. Then in order to make the reflected waves to meet at a particular point after reflection, we are going to use a parabolic surface in the halls. Okay. Then and also there is a reflecting surface which is in the shape of an ellipse. That is, here there is a reflecting surface which is an elliptical one. Like this means then wherever the sound waves strike on the walls of the elliptical surface, then the after reflection they are found to meet at the second focus. That means we know that the ellipse has two foci. Therefore, there is a person who is standing at the first focus and produces a sound, means then that even though the sound is very much smaller, very much weak, then that can be clearly heard by the second person who is standing at the second focus. Then it is the basic principle of the construction of whispering gallery. Okay, therefore the whispering gallery has an elliptical reflecting surface. Then even we are producing a very weak sound that are traveling in all the directions, that will be reflected by the elliptical surface to the second focus, wherever the sound producer is standing. Okay, then it is the basic principle in the construction of the whispering gallery. Okay, then right now we will stop. Then the remaining topic we will see in the next class. Thank you.